Hi, my name is Grady King. Today I'm going to be going over the sort of FRC robot components and the basics of electrical, how the whole system works. If you have some sort of test bench or something so that you can sort of follow along as I point things out, that would be sort of the best way to use this video. But I have a diagram that I'm going to be sort of scrolling around to show you everything. So yeah, let's get into it. So let me bring my webcam jack down. So here is the diagram that I have. It might be incredibly overwhelming, but we're going to start in this bottom right corner. If I can scroll over there. So the backbone of the robot is obviously the battery, because that's where all the power comes from. And we have these giant batteries, like yay big. They're either black or gray, and they have these huge red and black leads coming out the top. Make sure to never grab it from the top by the leads. Make sure to grab it by the housing every time. But you'll see them on a sort of cart or strewn across the place because we use them all the time. The next most important thing is something called the breaker. We have a 120 amp breaker, which means that if 120 amps somehow flows through the breaker, it'll stop because 120 amps is incredibly dangerous. So that basically makes it so that the robot is a lot safer and less likely to short on something for an extended period of time or something like that, which could be extremely dangerous. And the way that you use the breaker, this red button here that you see, if you push that, it'll open the breaker, which means that power won't go through it. And the way to close it is you just squeeze on the little flap that is in it, and you'll close it, and then it'll be a nice snap sound. And that means that power is running through the robot. Make sure to always plug in the battery first before you turn on the breaker. And make sure you hit the breaker to turn off the robot before you ever disconnect the battery. But anyways, these wires now go into this thing, this huge thing, which is called a power distribution hub. This is by REV. There's a separate one called the power distribution panel, which I'll go over the second system later. But we used this power distribution hub last year because it has so many outputs. You see there's each of these pairs of red and black leads is something that can be powered. So there's 20 different slots for motors here, and then you see they're numbered. I'll have this diagram in the description if you want to look at it. So basically the power comes into here, and then it'll give you a voltage, and there's a bunch of different components here. So each of these outputs here, like I said before, these red and black wires go into a high power component. So for example, the Falcon 500 is probably our most commonly used motor, and that gets power from, you see this is from the 16th port of the power distribution hub. There's things called motor controllers, which are used for basically every motor other than the Falcon 500, which power goes into the motor controller, and then the motor controller controls the motor itself. And I'll explain everything about motors and all the nuances and stuff in a later video, but that's sort of the idea. So the two most commonly used motor controllers are the Spark Max and the Talon SRX. We most commonly use the Talon SRX because it's a little bit less buggy. Sparks can be a little iffy sometimes. And Sparks are also a little bit more dangerous because there is one setting that can either make it so that it runs fine or completely kills a motor. So we normally use Talon SRXs because they're a little safer and they're a little more reliable. But you might see these on like an older robot like Marvin 13 or something like that. But yeah, they get power from the power distribution hub. let's go to the next most important thing, which is the RoboRIO. And you see that it gets power from, I need to follow the diagram, comes around here. So it gets power from one of these 4 smaller voltage output leads, and that just comes into the RoboRIO here. And the RoboRIO has a bunch of different inputs and outputs, obviously, but there are these status and power lights here. Let me zoom in a little more. There are these power and status lights here, which are important to know, so that you know if it's plugged in correctly. And there's a few different lights here to indicate different things. One important thing that the RoboRIO does is it powers the robot signal light, and you'll see this on every single FRC robot because it's required for it to be legal. What it does is whenever the robot's disabled, it'll be solid orange, and whenever the robot's enabled, it'll be flashing orange on and off. And that means that it's enabled. Obviously, the robot's dangerous, so that means to step out of the way. And it's also important for if you ever start to reach into the robot to grab like a nut or like fiddle with wires or whatever, you want to make sure that RSL light is solid orange, so that there's no chance of you getting hit by a motor or something like that. Another important thing is this Ethernet port, and this goes to the radio. So this Ethernet cable will go into this thing called the radio power module. It can also potentially just go straight into the radio. There's a few different configurations for that. But this radio power module essentially makes it so that this power coming in and this Ethernet can go straight into one Ethernet input into the radio to save on sort of the massive headache it is to set up something called power over Ethernet. It's kind of annoying. But yeah, that's essentially the way that the RoboRIO can communicate with the radio, and the radio gets power. The radio is the way that we communicate with the robot. We communicate through Wi-Fi. So you'll be spending some time in this Wi-Fi menu connecting to radios, and I'll describe how to configure a radio and how to configure RoboRIOs in a later video. But it's important to know that that's what these 2 components do. There's a few other inputs in here. A few commonly used ports is the DIO, which is I think it's digital input output, which basically means a digital input is basically on or off. So this is used most commonly for something called a limit switch, which is sort of if you put a magnet near a limit switch, it will read true, and if the magnet moves away, then it'll be false. And that's a way to, for example, on Martin 15, there was a metal bar and an arm that would move back and forth. It's a way to detect if the arm is near the bar, and it's a way to basically detect if it's going to stop. So that's an important thing for the DIO. There's a few other things like analog. Analog in is used for, there's multiple ways for most sensors to be used. Analog in is sometimes used for something called IR sensors, which is it's an infrared sensor, and essentially it fires out infrared light and then detects how long it takes for the light to get back to the sensor, which can detect distance. PWM is important to know about. It was basically the way that we used to control motors. Essentially, it would send out a signal to a motor. So, for example, this motor controller called Spark. It's important that Sparks are different than Spark Maxes. Sparks are controlled by PWM. PWM used to be the way that we communicated, but the system called CAN is what superseded that, because it's a little bit more, it's a lot easier to set up, and it's a little more reliable. So speaking of CAN, this is where the CAN bus normally starts, is on the RoboRIO. And CAN is these yellow and green wires. Remember that the power are these red and black wires. CAN are these yellow and green wires. And normally they're twisted around to make them stronger. But you'll notice if you zoom out that this CAN wire goes to the power distribution hub, and it also goes to all of these motor controllers, and it goes to the Falcon 500. The CAN goes in and out of a motor because essentially how it works is it's daisy chained. So instead of having to have an individual wire go to each motor, essentially what you can do is if you have like 1, 2, 3 motors, you just connect CAN between each of them, and then the whole chain is able to communicate. And so that's what's important to know about CAN. There's a bunch of nuances with CAN, some of which are quite annoying, which I'll talk about later. But it's important to know that CAN is how it communicates. So any motor or motor controller, for it to be on and communicating with the robot, needs to have both the power from the power distribution hub and CAN communication from these CAN wires. Alright, so another component of robots is something called pneumatics. And pneumatics are a way, it's a way to control movement by air. And so what we have is something called a compressor, which compresses air, and this compressed air goes to something called solenoids, which solenoids basically control the direction of air. And these solenoids are connected to something called a pneumatic. And that allows for movement, certain types of movement, and allows for very quick movement that is very unlikely to damage anything. And it's basically it's very useful in terms of the movement that it can give. If you look at Marvin 15, the intake is controlled by pneumatics, as well as the climbing system is sort of half pneumatic and half motor. The movement back and forth of the arms is controlled by pneumatics. So pneumatics are very useful, and the thing that controls pneumatics is something called the pneumatic hub. It's also called the pneumatic control module. The REV pneumatic hub we had some issues with, so you might see the pneumatic control module. But yeah, essentially power and CAN comes in, and this just communicates with things like pressure sensors and the solenoids and the compressor in order to create compressed air, communicate with the solenoids to provide the direction of air, and sense whenever the compressor should turn on and off, depending on what pressure we have, things like that. And I'll talk about pneumatics a little more later. But yeah, another component is something called a voltage regulator module. And this is something that powers sort of lower voltage components. One thing that's powered on Marvin 15 is something called the CAN coders. Those are they're very useful, small sensors that basically can sense the direction of the swerve module. If you've ever seen a swerve module, it like spins around like this, and there's a wheel that spins like this, so you can spin and move at the same time, and it allows for a very complex movement. But essentially, voltage regulator module controls that. And you'll notice if you zoom in a lot, each port has different outputs. Like this is 5 volts 2 amps, 5 volts 500 milliamps, etc. You won't necessarily need to worry about it, but if you are setting up some sort of sensor like that, make sure you're being careful about what port you're plugging into. But yeah, that's actually sort of it. Let me go into the CTRE diagram, because these components are essentially the same but can look a little different. So if we go over here, you see here's where the battery is, and this is the breaker, and it goes into something called the power distribution panel. And you notice that there's a lot less ports coming out of here, and there's only 8 larger voltage and amp outputs here, and then there's 8 smaller ones. So it was a little bit more limited in how many motors you could use. So that's why we switched to the REV one, because it had a lot more ports. But you notice here's the power distribution panel. It's the same as pneumatic hub. Pneumatic control module is very similar to the pneumatic hub in the REV system. The voltage regulator module, I think, is the same thing. And this is the RoboRIO 1. Over here is the RoboRIO 2, and it has a little bit more ports, and it has a little bit more features. But you'll see there's the RS outlet, there's the solenoids. It's sort of the same thing. So on a test bench, you might see some old sort of CTRE panels and stuff, but just know that it's essentially the same thing, and they have very similar names, so they're pretty much comparable. But yeah, that's essentially the robot, the system that everything runs on, and it's important to know how it works and be able to sort of diagnose issues. It can be tough to really know like why a motor isn't working. Sometimes it's electrical, sometimes it's programming. So you just have to work with electrical. I'm very good friends with Thomas because he was the electrical lead. We worked together on a lot of issues, so it's important to be very familiar with all of this. And yeah, but yeah. I would say a challenge that I would give you is to go to either one of your friends, a different new programmer, or go to an experienced programmer and explain this whole system to them, because explaining things is really, and teaching is really one of the best ways of learning. So that's my challenge to you. And yeah, have a good day.